This lesson is on finding limits analytically. This is section 1-2. So let's review what a limit is. You'll recall from the last section, we were finding limits graphically. So we would graph the particular function and then we would find the limit as x approached a certain value, find out what value y would approach, okay? So that was, we were able to do that via the graph, via the picture, if you will. Now this is going to be finding a limit analytically, okay? So we don't have the graph, we've got the function, but we don't necessarily have the graph, and we want to still find the limit. So there are different ways that we can find a limit analytically, okay? And let's see. So the first way is simply direct substitution. We simply substitute in the value for x and see what the value is for y, all right? So that is one way we can do it, direct substitution. The second way is we simplify first and then we do direct substitution, okay? Well, how can we simplify? We might be able to factor and cancel, or we might have to rationalize if we're dealing with square roots, okay? So factor and cancel, rationalize if you got square roots, and then we can try direct substitution, all right? And then the last is something we're not going to deal with right now, but we'll talk about it later, is L'Hopital's rule. Now this is where we end up with an indeterminate form. In other words, we could either have 0 over 0 or infinity over infinity. And how do we handle that? How do we come up with a limit? And we will have a rule for that which makes it pretty simple. But we're not going to deal with that right now. Right now we're just going to talk about direct substitution and then simplifying and then direct substitution. So let's start with direct substitution. I've got two examples here. I've got the first one here, which says the limit as x approaches 0 of x squared minus 4. And then the second one is the limit as x approaches 2 of the square root of 2x squared minus 4. So let's look at the first one here. The limit as x approaches 0 of x squared minus 4. So we simply plug in x equals 0. If we plug in x equals 0, we get 0 squared minus 4, or the final answer is minus 4. Pretty straightforward. Now, if we had the graph here, we'd have a parabola. We'd have to look at it from different perspectives, but this, in a way, is a lot easier than having to deal with the graph. Let's look at the second one here. The limit as x approaches 2 of the square root of 2x squared minus 4. Again, we're going to plug in x equals 2, all right, right there. Square it, multiply by 2, subtract 4, and we end up with the square root of 8 minus 4, or the square root of 4, which comes out to be 2. So here are two pretty straightforward examples of direct substitution. So what if direct substitution doesn't work that well? For example, if you look at the first one here, the limit as x approaches 0 of x squared minus 5x over x. Well, if I plug in x, I'm dividing by 0. So that's not going to work. I can't divide by 0. And even in the second one, I'm saying as x approaches 2. Well, if I plug in 2, the denominator is also 0. So that's not going to work. So what we're going to do is something, we're going to try to see if we can factor and cancel and then do direct substitution. So let's look at the first one here, okay? We said that direct substitution would work because we'd be dividing by 0. So let's factor the numerator. So I got x squared minus 5x. Well, that simply factors to x times x minus 5. Well, I've got an x and an x, so I can cancel out the x's, and I have the limit of x minus 5 as x approaches 0. Now I can plug in 0 for x, and I come up with my answer, minus 5. Let's look at the second one. Again, if I plug in x equals 2, I've got a 0 in the denominator, so that's not going to work. I don't want to take and divide by 0. So if I take the numerator, x squared plus x minus 6, and factor that, that factors to x plus 3 times x minus 2 over x minus 2. Well, the x minus 2's cancel, and we just have the limit of x plus 3 as x approaches 2. Well, if I substitute 2 for x, what do I end up with? I end up with my answer of 5. Here's another example. I've got the limit as x approaches 5. Well, again, if I plug in x equals 5, I end up with a 0 in the denominator. That's not going to work. So look at the numerator. Well, I can't really factor anything in the numerator. I got a radical here and a minus 3. So let's see how I'm going to handle this. So in this case, I'm going to rationalize. Now, see if you remember how we rationalize. Okay, look at the numerator here. We got the square root of x plus 4 minus 3. So if I multiply that by the square root of x plus 4 plus 3, but remember, whatever I do on the top, I got to do on the bottom. So I'm going to multiply the bottom also by the square root of x plus 4 plus 3. Now, if you multiply the top, and if we FOIL this, what do we end up with? We end up with the square root of x plus 4 squared, which is simply x plus 4, minus 3 times 3 minus 9, okay? The denominator, x minus 5 times the square root of x plus 4 plus 3, down here. Now, let's not multiply this out initially, all right? We don't want to multiply this out initially. So I got the square root, I'm sorry, in the numerator I got x plus 4 minus 9, which simplifies to be x minus 5. Well, look what I got in the denominator, x minus 5. So I can cancel those out, and I simply have 1 over the square root of x plus 4 plus 3. Well, now what happens if I plug in x equals 5? If I plug in x equals 5, I have 5 plus 4, which is 9. Square root of 9 is 3. 3 plus 3 is 6. My final answer is 1/6. So those are the 3 ways that we can take and find the limits analytically. Direct substitution, factoring, cancel, and then direct substitution, or rationalizing and then direct substitution.